Hi everyone, this is Teacher Jane again. My lesson for today is how to find the area of a circle, the sector, and the segment. The examples that I'm going to use were lifted from the Mathematics 10 Quarter 2 module, pages 20 to 25. Before we move on to our lesson, let us first start by reviewing some basic concepts about the circle. Let us start our review by answering Learning Task 1 in page 20. Use the figure below to match the definition or description in column A with its correct representation in column B. Number 1. A line segment, a line, a ray that intersects a circle at point B. There should be point B here. The answer is letter D. It is line BC. Let me write D. Number 2, the point of tangency between a tangent and a circle, which is this one. So you have point B, letter E. Okay. Number 3, a line segment, a line and a ray that intersects the circle at exactly 2 points and is also called a secant line. Okay, then we cross out this one. That's a typographical error. So what's the answer? It's letter F. Number 4. A secant segment is a segment with one endpoint on the circle. So number 4 is letter B, segment DC. Next, number 5. An external secant segment is part of the secant segment that is outside of the circle. So we have this external, okay, segment that is also part of the secant line. So we have segment EC, letter C. And lastly, the tangent segment is a segment whose endpoints are the point of tangency and the fixed point outside the circle is letter A. You have segment BC. Okay, so I have answered and reviewed already learning task 1 on page 20. Our new topic for today has many applications in real life. One of them is the problem that I'm going to show you. Mrs. G ordered a regular pepperoni pizza. She was asked to choose between a square or a round pizza at the same price. Can you help Mrs. G decide which to buy? The square pizza has a dimension of 8 inches by 8 inches, while the round pizza has a diameter of 9 inches. Now, I'm going to pause this video and I want you to think, which do you think is best buy for Mrs. G? Okay, so maybe most of you are saying it's hard to tell. Now, after learning our topic for today, we are going back to this problem and you can answer this as accurate as possible. To help Mrs. G decide which pizza to buy, whether is it the square or the round one, you have to know how to find the area of a circle, which is the region occupied by the circle in a two-dimensional plane. The formula in finding the area of the circle is equal to pi r square. The value that we use for pi, okay, is the constant 3.14. So let me write here pi is equal to 3.14. R here, okay, is actually the radius of the circle. So we only have a constant 3.14 and an unknown R, or the radius of the circle. So to illustrate a round pizza, okay, it is given that the diameter is 9 inches. Okay, let me write there, it's 9 inches. Since the diameter is twice the radius, it means that we have to divide 9 by 2. Therefore, the radius of our round pizza is 4.5 inches. Now, let's use now the formula A equals pi r square in finding the area of the round pizza by substitution. For pi, we have 3.14, and then for r, we have 4.5 raised to the second power. Then we have 3.14 multiplied to 20.25, which is for the value of 4.5 raised to the second power. Multiplying both, we get 63.585 rounded off. We have 63.59 square inches. So that is the area of the round pizza. Now let us go back now to the problem and check whether what Mrs. G should really decide on. We can now help Mrs. G decide which pizza to buy. Is it the square, which is an 8-inch by 8-inch square pizza, or the round one, which is a diameter of 9 inches? Remember, in finding the area of a square, you have to multiply only the sides. So we have 64 square inches is the area of the square pizza. And the round one is 63.59 square inches. We can now decide, okay, that the square pizza has a bigger area. Okay, looks can be deceiving. The round pizza might seem big, but you cannot be deceived if you know how to find areas. Let us now move on to the next topic. The next topic is how to find the area of a sector. What is a sector? It is the region bounded by two radii and its intercepted arc. So here are some illustrations of sectors. Example, in the first one, you have here 1/2 of the whole area. It is bounded by two radii. So you have here and another one and its intercepted arc. Okay. The central angle here has a measure of 180 degrees. Therefore, this portion of the area of a circle can be represented by 180 over 360 degrees. Or simply, it is 1/2 of the whole area of the circle. While the second one, okay, has a central angle of 90 degrees. Therefore, this one can be described as 90 over 360, part of the whole area of the circle, or simply it is 1/4 of the whole area of the circle. The third one is 270 degrees, okay, over 360 degrees, or simply it is 3/4 of the whole area of the circle. So therefore, what is the formula in finding the sector? So simply, the central angle plays a great part of the formula and as well as the radius. So here is our formula. Okay. A is equal to theta over 360 degrees, which represents the part that you took from the whole area of the circle multiplied by pi r square. Pi r square is the formula in finding the area of the whole circle. So it's like part taken from the whole. So we will now use this formula, okay, in finding the area of given sectors in the next slide. Let us now apply how to find the area of a sector in this given problem. So I have here, okay, this pink shaded area, okay, and we have to find, okay, its sector or the area of the sector. The radius is 4 units, and theta here, which is the central angle, is only 40 degrees. Knowing that the formula is theta over 360 degrees multiplied to pi r square, we start with, okay, formula. Then we are going to substitute. Theta is the given central angle, 40 degrees. Our pi is 3.14 and our radius is 4. Following this formula, 4 square is 16. Okay, so we have 4 square is 16. Then change or simplify 40 over 360
to 1 over 9. Anyway, you can skip this part. If you have a scientific calculator, you just simply press all these things, okay, all these values, and you get to calculate the answer instantly. Next is we multiply 3.14 times 16. The area of the whole circle is 50.24 square units. But we are only getting 1/9, okay? Or this is the part that you are getting, or the sector. So 1 over 9 multiplied by 50.24, that will give you 5.58 square units. So this pink area here, or sector, is only 5.58 square units. So that is how to apply, okay, the formula in finding the sector of a circle. Moving on, let's have another example. Okay. Find the area of the sector of radius 6 centimeters and the central angle of 70 degrees. So, our radius this time is 6 centimeters, and given our central angle is 70 degrees. So, to illustrate, this is how it's going to be. Then, step 1 is the formula of the sector. Okay, then we substitute for theta, which is 70 over 360, our constant value of pi. Then 6 is our radius raised to the second power. We have 36 here. And I just canceled both zeros from the numerator and the denominator. So you have 7 over 36. Again, you can instantly calculate this by pressing all of this in your scientific calculator, and you get an instant answer. Now, multiplying 3.14 times 36, this is now the area of the whole circle. But we are only taking 7 over 36 part, okay, which is represented by the sector. So, multiplying it, we get only 21.98 square centimeters. So, that is the area of the sector in this example. The last topic that we're going to learn is finding the area of a segment. So what is a segment? It is the region bounded by a chord and the intercepted arc. So if I'm going to write here, we have segment AB, which is this chord, okay, and the arc, okay, that touches the endpoints of the chord is also arc AB. So this portion here, the yellow part, which can be visualized as like the crust or the edge of a pizza, is what we call as the segment. So basically, how do we solve for this? So we have a general formula for this. Simply we solve for the area of the sector. So to visualize, this is the sector or the part, okay, of the whole area of the circle. Then we simply subtract the area of the triangle. So minus the blue one or the triangle. Okay. So what is left is the segment. So what we may call it as the crust of the pizza. So that's how, okay, the general formula works. Okay. So there are two things that we have to know. The formula in finding the sector of a circle, and the formula in finding the area of a triangle. So moving on, okay, this is our formula. Segment is determined by using theta over 360 degrees multiplied by pi r square. This is actually the formula for sector. Okay. Then subtract 1/2, okay, base times height, which is the basic formula for a triangle. Okay. although from what we have learned in the past, okay, there are other formulas in finding the area of a triangle. Anyway, I'm going to show that in my next slide. So let us now apply this formula. So let's have our first example in how to apply the formula in finding the segment of a circle. Find the area of the segment bounded by a 90-degree central angle and a radius of 10 centimeter. So to illustrate this, we have here this blue area for the triangle and this part, which is the segment. So our radius is 10 centimeter and the central angle is 90 degrees. So our plan is to first solve the area of the sector. Then it will be followed by solving the area of the triangle. So to solve for the area of the sector, we are going to use the formula theta over 360 multiplied to pi r square. So our angle has a measure of 90 over 360 degrees multiplied to 3.14 times 10 raised to the second power. So we have 1/4. So I have to simplify 90 over 360 multiplied to 3.14 times 100. 3.14 times 100 is 314. So that's actually the area of the whole circle. But we are going to take only 1/4 of that. So 1/4 of 314 is 78.5 square centimeters. So that is our area of the sector. Moving on, we are now going to solve the area of the triangle. Since the triangle here is quite easy to solve because our triangle is a right triangle, therefore, we already have our base, okay, and our height, and the height. Now, the base and the height here are actually the radii of the circle, and they're just both 10 centimeters. Now, do remember that the base and the height of our triangle should be perpendicular to each other for it to be considered as the base and the height. Okay, remember that. So, moving on, let us now solve for the area of the given triangle. So, formula is 1/2 base times the height. So, 1/2 times 10, which is the base, times the height, which is also 10. So, we have 10 times 10 is 100. Then get 1/2 of that. So, the area of the triangle is 50 square centimeters. Now, to find the segment, we simply subtract the area of the triangle from the area of the sector. So, we have here, the segment is 78.5, subtract 50, so we are left with 28.5 square centimeters. That is now the area of the segment. Okay. In my next example, we are going to encounter a different kind of triangle, which is not anymore a right triangle. In my last example, you are going to learn how to find the area of a sector if the given triangle is a non-right triangle or an oblique triangle. So example, find the area of the segment of radius 2 cm and bounded by a central angle of 120 degrees. So to illustrate this, you have this figure. So this is our radius, and then here's our central angle. Now do notice that our base is this chord and the height is the segment perpendicular to the base. Okay, and they are not yet given in the problem. So the same plan, okay, that we are going to use to solve, we have to solve first for the area of the sector, then we subtract the area of the triangle. But this time, we are going to use a different formula in finding the area of the triangle, okay, since it's not a right triangle. So to start with, let's solve first for the area of the sector. So given this formula, we are going to substitute. So we have 120 over 360 times 3.14 times 2 square. So lowest term is 1/3 times 3.14 times 4. Then the area of the whole circle is 12.56. But we are going to get only 1/3 of that. and that is 4.14 square centimeters. Okay, now moving on now, what formula are we going to use in solving the area of this obtuse triangle? So since what is given is a side, which is represented by the radius, okay, and another side, okay, and an included angle, we are going to use Heron's formula, okay, in finding the area given a side angle side. Okay, again, we are going to use Heron's formula in finding the area of a triangle whose given are S, A, and S. So here's the formula in finding the area of object triangle given S, A, S. Okay, it is 1/2 r square multiplied to sine theta. That r square is actually a times b. But since our a is r, and our b is also r, so it means r times r. So simply, we can say that it is r square. Now, applying this formula, we get, okay, a is equal to 1/2, r is 2 square, then sine 120 degrees. In this case, you really need a scientific calculator to solve for sine 120 degrees. Moving on, okay, so 1/2, 4 is 2 square. The value of sine 120 degrees is 0.866025438. Actually, you can press all of this in your calculator and you can get an instant answer without writing them. Now, multiplying all of this, we get 3.464101615. Then we are going to multiply it by 1/2. Therefore, we have 1.732050808. Then, rounded up, we get only 1.73 square centimeters. So, that is the area, okay, of this triangle here, the obtuse triangle, or what we call as the oblique triangle, the grade 1. Now, to continue, we are now going to solve for this segment, okay, in blue area. So, simply, we subtract the area of the sector, 4.14, minus the area of the triangle, 1.73. Then, the answer is 2.41 square centimeters. So, that's the area of the segment we are looking for. So, I hope I was able to help you understand these three concepts: area of the circle, area of the sector, and area of the segment. Now, if you have questions about these lessons, you can actually write your comment below, okay, in my YouTube channel. And please, I hope you can subscribe and click the notification bell for you to receive updates of my new videos. Okay, with that, I'm going to see you again. I am already preparing my next video about arc lengths, okay, and I hope you will find time watching my next video. Bye-bye!